Hello, welcome to the second video. This one's on the row space. The previous video was on the null space. My name is Nakia. Remember, I'm happy to help you make it through this linear algebra journey. What is the row space? Let's start with an M by N real matrix. M rows, N columns. Think about each of the rows. How many components are in the row vectors? Treating the rows like vectors will have n components. These rows are in Rn. And what we do is we take the span of those rows. What vectors can I get to by linearly combining the rows? That's what the row space is called. Okay? And we write it as row space, one word, row space of A. So just take a generic matrix. In this case, we're 2 by 3, and we have two rows. We have the row 2, negative 1, 3, and the row 5, 9, negative 7. The span of that is your row space. But the question we'll be interested in is what's a basis for the row space? And you can't just take the rows that you have and call it their basis. Okay. All right, great. So what about row reduction? How's that work with this? Well, that's going to be the key. We're going to row reduce down to row echelon form. And if two matrices are row equivalent to each other, if they can get, you can get from one to the other by row reduction, then the row space of the first one will be exactly equal to the row space of the second one. And so it's going to be the set of non-zero rows. Once you get into row echelon form, that will make up the basis for the row space. Non-zero row vectors when you're in row echelon form. That'll be your basis for your row space. All right, well, here's an example. Find a basis for the row space. You can't just take the span of those three rows. We want to go into row echelon form and just take the actual rows that are left, the non-zero rows. So let's see here. Oh, it's in perfect situation where we could just have the 1, 1 spot be a 1 already. We need the numbers underneath that to be 0. We'll do our subtraction, row 2 minus row 1, and then we'll triple row 3 and negate it and add it to row, triple row 1 and negate it and add it to row 3. And we'll get our zeros. We're not in row echelon form yet, but we're close. We have some options. Usually the option is to avoid fractions. But here we go. At least two of the numbers there in that row are even. So when we take half of that row, we're only introducing one fraction. It'll be the 3/2 that's there. But yeah, we're going to take negative 4 row 2 and add it to row 3. We'll get our 0 underneath that 1. Technically, we're not in row echelon form. Remember, the first non-zero entry in the row needs to be a 1. So we'll do this scaling again, although it's introducing fractions. Our goal is to get into row echelon form, and by taking 1/6 of row 3, we'll get there. Leading 1, staircase down, no rows of zeros. If there were a row of zeros, it'd be on the bottom. And so we've reached row echelon form, and according to what we had on our last slide, these exact rows here form the basis for the row space. Okay. Later, we're going to call the dimension of this basis. We'll call it something later, something very familiar to you that you've seen before. But that's it. That's our example on finding a basis for the row space, or explanation of what a row space is. And in the next video, once we get through introducing the column space, there'll be another video where then we'll connect the row space and the column space and the null space. We'll connect it all together. Thank you for watching. My name is Nakia, remember, and I'll see you in the next video.